Welcome everyone for this last session of Devox UK. I hope you're going to enjoy yourself. So Aurelien and myself will be talking about caching 101 on the JVM and trying to go a bit beyond. First of all, a quick overview of the different topics we want to talk about today. So first thing, a bit of caching theory. Even though it's not like the latest, coolest, sexiest concept, you realize that in the enterprise world, caching still plays an important role, and people sometimes do not understand or comprehend fully what it means and how to leverage it properly. Then we'll have a look at caching in Java, because after all, this is the main topic for us. So if you're here to listen about memcache or other technology outside of the JVM, that's not going to be the focus. We're going to describe a number of caching patterns, hopefully doing some demos to show these. We've rehearsed all of them, so they will break, but that's life.
If they don't break, it's not good.
Yeah. And then finally, look a little bit, and that's the and beyond, of what you can do in order to do even more caching for your Java application by scaling, either up or out. But maybe a quick introductions of the two of us is a good thing. So he's Aurelien. He's been working at Software AG, which is the company that bought the startup Terracotta in 2011, and he was there before that. So he was a proud startup days developer.
Anybody knows Terracotta? Yes.
Cool. He's been coding for a while. He says he probably will never stop. We'll see about cramps in the end at the latest moment, but and he has a number of open source projects, one of them being the Rainfall performance testing framework that we happen to use internally, so at least it has less bugs than it could.
Yes, and I'm French.
Okay.
Yeah.
But I'm too, so.
And he's French too. So he is a principal software engineer at Software AG, meaning that is very important for us.
Come on, it's the only title without manager or architect.
Yeah. Thing is, I wanted to make fun of him, but he's a manager as well, so I have to pay attention. So yeah, he's really coding and responsible basically of all the EHCache 3 development, leading the team of EHCache 3. So EHCache 3 is our current version of EHCache. So anybody knows EHCache 2? Yeah. So, and who knows EHCache 3? Nobody, cool. So it's good that you came today. And he has a lot of different interests from concurrency to API design, and he likes to learn new things, and he likes Gradle, so nobody's perfect, but.
But that's for us. But we're still interested to understand a bit better who you are, guys, so that we know what we should say and what we shouldn't. So who knows nothing about caching? Okay. Who already uses some form of caching in their production application? That's good. Keep your hands up. Who had caching-related problems in production? Oh, a few hands went down. That's cool. Congratulations. And yeah, Aurelien already asked it, so EHCache anyone? So clearly the goal today is absolutely not to go over EHCache specifically. There are resources on the web for that. We really want to stay at a higher level so that what you learn today should be applicable by using most of the large open source caching providers on the market.
But we will use EHCache as the caching provider for our demo.
I mean, there is a little bit of product.
Yeah.
A citation from some famous guy. So there are only two hard things in computer science: cache invalidation and naming things. We will not deal with one of them today.
Naming things. I mean, it's when I got my first baby that I understood that it was true. Who knows Phil Carlton, by the way? Nobody? Yeah? So who knows X Windows? Yeah. Who knows X11? Okay, same guy. Who knows the X Windows system? Who knows X? Okay, so these four things is the same thing. It's just four different names. And that's the guy who led the development of X Windows. So he knows really about naming things. It's very difficult.
So let's get with the meat. A bit of caching theory. What the heck is a cache? Anyone wants to try it out and see if we agree? Some form of data structure holding temporary copy of some data. Pay attention to the temporary. That's why it's in bold and italics. We cache developer people tend to be have strong opinions on a number of the things we believe a cache is. Temporary is clearly one of them. It's a trade-off between higher memory consumption in order to benefit from reduced latency in your application. So you will have more data closer to your application, more memory consumed, but you hope that you then not have to go fetch that data to that crazy slow database, which is 2 data centers away, has firewall trying to run antivirus scanners in the packets coming in and stuff like that. Which means what we're targeting in order for caching, it's data which can be reused. Obviously, if you have a very, very long computation, but you're only gonna ever use that result once, there may not be a need to cache it. And the second thing is, of course, we expect the data to be either expensive to compute or expensive to retrieve. Because otherwise, what's the point of consuming more memory? But with that, the question is, okay, but that's good. Why does caching work in a way? Well, the first thing is, when you think about what your applications are doing and the IT world and the IT stacks in general, you've got something called the locality of reference, which you see mostly access patterns. And sometimes it's the values you're accessing are either the same or a close-knit group related to each other. And so in that context, you frequently end up accessing a very known subset of the data. It doesn't mean not all of the data gets accessed at times, but you access a subset of it. And this is one of the way you can do predictable behavior analysis on application and other parts of the IT stack. And if anyone knows a little bit how a CPU works, well, this is one of the reasons. Like branch prediction on CPU are based on that. They expect you, oh, I've seen that code path, and 99% of the time, they take the left branch. So I'm going to, ahead of time, compute the results of the left branch, because that's what I'm expecting to see being requested next. And you know what? In the 1% of case it fails, well, anyway, I want so much time the other times that it's still good enough.
Which is exactly the same behavior as on the cache. It's you try to get something from the cache. If you don't get, it's okay. If you got it, you save time.
Yeah. And as I've said, that principle gets applied at multiple levels. CPUs, L1 caches, L2 caches, the complexity of NUMA architectures where you actually have different caching region and stuff like that. Network, there is a cache over the network. You don't want to transfer always the same data, especially when it's repetitive or you're asking the same thing. Operating systems have caches themselves, or they will even do stuff like preloading your application. I think one of the Windows version does that, like based on your usage pattern, it will load that game at 6:30 because work is over. So that's the reality of the world we live in. And so with all of that, well, it ends up being a desirable feature in an application, because if you've got that locality of reference in your application, even without explicit caching at the application level, you're actually leveraging the machine and the stack you're building on. Some people may know about the mechanical sympathy. There are links to that because, yeah, false sharing, some of the proposed Java enhancement proposals for the future version of Java talk about that, trying to make sure that when an object is accessed, you don't suddenly invalidate cache of neighboring object, and instead you focus just on that object and stuff like that. So that's one of the reasons, this locality of reference. The second thing that goes there is what's called the long tail. And so it was coined by Chris Anderson from Wired Magazine. And in short, it's the application of a power law probability distribution. And if you think about the Pareto law or the 80-20 rule, anybody heard about that rule? Yeah, a few at least. So 80% of the time, you're using a subset of the feature of your application, which can be derived in saying 80% of the time, you're using a subset of the data. And so if you can optimize for these use cases, well, you've got a huge return on benefit because that's the most often traveled path. So given that context, which explains why caching works, let's define a few terminology terms. You want to go?
Yeah. Okay, so when you talk about cache, you talk about getting data from the cache, and then what can happen is either you get the data or you don't get it. When you don't get it, well, actually, no, when you get it, it's a hit. When you don't get it, it's a miss. A cache, so like Louis explained, the point of the cache is to use some memory to hold a subset of the data structure, and given that this subset will be the most efficient to speed up your application. But we start with an empty cache, so when the cache is empty, it's cold. And what we call warming up a cache is a process of loading the cache so it gets this small percentage of data that will be very useful to speed up your application. So yeah, the warm up of the cache, it's when your cache is really in the most efficient state.
And the warm. So and yeah, the warm is when your cache really has what it needs.
Yeah, a warm cache. Yeah, sorry.
And it's pretty much stable. So this is a slide we added at the last moment because we realized while repeating the two of us together that we were using a lot of words.
Yeah,
and at one point, like, oh crap, these all make sense to us, but will they make sense to anyone? And so in the patterns discussion, in the different features that are upcoming in the rest of the presentation, we will end up referencing these. If we do end up using other terms that are unclear, and we should probably have said that at the beginning, please interrupt us and ask questions. This is going to be a 3-hour session. It's just after lunch. You all want to sleep, but we'd rather have your attention. And if we lose you now, we'll probably never get you back on track. So just be proactive and don't hesitate. We've got plenty of content if we go too fast, and we can probably cut stuff out if we go too slow. But I'd rather go too slow and have you getting something out of the presentation than just being said, okay, we're done. What else can we add? So don't hesitate.
But don't worry, the concepts are not very complicated because it's a lot of things which is, I mean, you're all using caches and you don't realize it, but even in a browser, you have a cache, so you all know about the concepts of caching. So most of the stuff will be quite obvious for you. It shouldn't be difficult to understand.
So, where and when use a cache? Well, first of all, CPU-bound application. So a CPU-bound application is an application where you can't make it faster because you end up having to do a lot of processing. Okay? And until recently, you could wait for CPUs to get faster. But now, the speed up you can get are based on two things: algorithm improvement, which may or may not be linked to the parallelization, but these are your two options. If you're today's world waiting for a faster CPU, we may have to wait a long time because of the constraint on the fabrication of these currently. And so in that context, well, obviously, if you can store a computation result, you don't have to recompute it anymore. So caching should help in that case. The other kind of application are IO-bound ones. And, well, there it's pretty cool. You can still wait for disk or network to become faster. The interesting thing there is that they're actually fighting with each other. So depending on the level of disk you have and the level of the network, it could be cheaper to go fetch data from memory from a different machine than fetching it from the disk. If you take like 40 gig Ethernet and a spinning disk, it's a no-brainer. But even with SSD and the latest network, I didn't check the latest numbers on NVM disk, so the new generation, which are really, really faster. If you can find a network that's as fast or even faster, but that gives you an indication that in the past, it was pretty clear. What's in memory, faster than what's on disk, faster than what's on the network. Well, these last two have been competing a while recently, and so pay attention to that. If you think you're slow from the network, putting it on disk may actually make may actually make matters worse. And of course, the cache there can help you, well, by storing the data locally. So if it's in memory locally, that still beats anything. But does that mean that caching is the perfect answer and you should cache everything always? Well, not really. Amdhal's law, a guy who coined the way you can gain speedups from parallelization. Okay? And so, well, it's math. I don't know about you, but I remember doing math while at school. But since then, I've been coding business applications up to the point I went back to framework. And, well, you don't necessarily do math that often. So I find that much more visual. So here, if we just look at the blue and the green line, so the blue line is the one at the bottom, and that's a line where the parallelization of your application is 50%. So you've got 50% of the processing in your application that can be parallelized, and the rest must be sequential. If that's what you have, the best speedup you will gain is a 2-time factor. After that, growing the size of the machine doesn't give you anything anymore, because you're bounded by the sequential bits. If we go to the 95% parallelizable, which honestly is a challenge, unless you're doing very specific mathematical computation that are like, what's the term again? Parallelizable, whatever, forgot the term. But so if you've got 95%, the maximum speedup still is 20 times. Which, depending on your requirements, well, may not be enough. So that's on the parallelization side. So that's kind of the impact you can have on CPU-bound applications. You'll be able to gain something, but you won't be able to gain everything. Like it's not like the sky is the limit. No, there is a real limit depending on what can be parallelized.
And actually, that's why a system like Hadoop got a lot of success, because the strong point of Hadoop is not about parallelizing tasks. The strong point of Hadoop is getting the data close to the execution of the logic of the data on which it works.
So there is a declination of Amdhal's law which talks about sequential. And so in the context of sequential, what happens is that this time you say that the speedup depends on what you could speed up and which part of the total process it was. Again, math are cool, pictures are better. So you've got two processes, A and B. They run in sequence, and A is the red bar, B the blue one. And so you see that if A takes a long time and B a shorter time, and you end up optimizing B a whole lot, like you make it 5 times faster, well, you mostly want nothing. The interest here is clearly to work on A. And again, it's something you've always heard. You've all heard. When you're trying to increase the performance of your application, you don't look about the internals that take milliseconds. You first look at the global request processing, and you find the most obvious time-consuming bit, and that's the first bit you try to optimize. And then you measure again, because optimizing that may have cascading consequences on the rest of the application. So clearly, what we see from there is, yes, caching can help you, whether you're CPU-bound or IO-bound. No, it will not be the magical tool. And definitely, you should measure. But if you think about it, we discussed that cache is about copying data. Man, that sounds scary. Because as soon as I have a copy of the data, I have a problem. Who knows about business applications where you end up having multiple users table or multiple things and they need to be kept in sync? A few still. But that's better than I expected. So the whole problem there is the coherence of that data. And so you would like the cache to have at least a number of rules about the way it's going to maintain that data coherence. So let's try to illustrate that. So I'm the process, is the location X, and what I'm doing is I'm writing something to it. Okay? When I come back later, I seriously hope I get what I wrote. and not something else, like his speaker card instead of mine. Okay? It sounds basic, but if you think about it, the moment you put a cache in front of the database and you've got another application doing writes, or even your application does writes without looking at the cache, you may hit that problem. You've changed the data, but you forgot to update the cache. You are now out of sync. You have inconsistent data in your application. The second one is, let's say this is the table, that's the location X. He's process 2, he writes something on the table.
Yeah, I write it there.
And I go get it.
Hey, wait. I didn't put it. Okay. Okay, I'm ready. I've done it.
Okay, and now I can get it. So here, the thing is, what? Well, if you're sharing memory, for example, the fact that you wrote to the memory, if you know a bit about the Java memory model, doesn't give you any guarantee that anyone else will ever see that write. You need to have the proper synchronization barriers in place. Otherwise, the JVM is authorized to optimize this write so that it's only locally visible. And at the cache coherence level, well, that's where you realize that IT and mathematics are not always the same, because you've got that returns A if enough time has elapsed, which means it depends. But it's actually a very important property, because depending on the requirement, the coherence requirement that your application has, that's where you can extract extra performance. If you're fine seeing a bit of stale data, well, you don't have to enforce strict consistency. But in cases where you must see the latest at all costs, well, you will usually see that this ends up being a bottleneck, because you have to wait for the cache to be properly updated. And finally, again,
two processes.
We write to the table, he writes something.
I write my name.
And I write something on top of it. Here the logic is what? I don't want a third party to ever see what I wrote last, and then later see what he wrote.
Yeah, mine is gone.
And of course, on a single machine, single thread, you realize, wait, but that makes a lot of sense. But think about a distributed system where you've got a peer-to-peer architecture and replication of the data. You can, in systems like Cassandra, say, I want to read, and I don't care. I want the fastest read available, which means I'm going to contact a single replica, and the first replica that answers, I'm going to assume that's the result. Of course, when you do that, you're opening yourself to that kind of race. Because if the data is replicated on 3 nodes, you could be talking to one of the nodes that doesn't yet have the mutation. And so you may be able to see these out-of-order operations. Again, is it a big problem? No, as long as you know what you're doing and you realize what can happen if you have such low consistency requirements. Reaching the end of that theory bit. So from all of what we discussed, what we can say is that we've got a number of desired cache features. The first one is capacity control. If you think about it, we've been talking that a cache will consume more memory to reduce latency. The day your JVM crashes with an out-of-memory exception, your latency will spike. I mean, it becomes infinite in theory. So you clearly want to be able to say to the cache, oh, please, yes, use more memory, but in a limited fashion. I don't want you to go crazy. And so that's the process we call eviction. And so here, what happens is that the cache will control the amount of memory it uses by evicting older elements. Older meaning what? Well, it depends. It depends on the cache implementation. It depends on potentially the eviction algorithm that the cache implementation allows you to configure. Some example can be first in, first out, probably not the most efficient. But you can also have stuff like least frequently used or last recently used. So these are different options there. Then the second thing is, again, temporary copy of the data. You probably don't want that temporary copy to become permanent. And so you really want to be able to express that this data has some freshness associated to it, and it should not outlive something, a given amount of time, let's say. And that's the expiry process. Most cache implementation out there will allow you to indicate either at the cache configuration or when you do an operation on the cache that what you're actually putting in the cache should be there for the next 10 seconds, the next 5 hours, the next 24 hours, or even the next week. That really depends on what your data represents. But this expiry process is really important, and that's what makes, combined with the eviction, a cache a bit more than a map. Let's be honest, if you don't want eviction because you just want to have in memory your static data of your application, and that data never expires because the only way you can change that is by actually restarting the database, which means you restart the application, you probably don't need a cache. Do it with a map. It's going to give you the same thing, and you don't need to pay the cost of having a system that handles both eviction and expiry.
And these two concepts, these two concepts are really important regarding the Pareto law that Louis was talking about earlier, because we really want to optimize what's inside the cache to hold a subset which going to speed up your application the most efficiently. So this is really something you need to pay attention to when you are using caches, is really to measure what you put in your cache. Just not take a cache and then I don't know the size, I will put unlimited, or I will put like 1 gigabyte, 10 gigabytes. You really want to measure, try some different configurations and see what is impact on your application.
Yeah. So yeah, because indeed, let's say you've got a hot set of 20 entries. Well, there is a huge difference if you size your cache at 15 or at 25. The memory difference may be limited, but if you size your cache at 15, well, you're going to miss 25% of the time on your hot set, which means you're going to have to go to the database, reload the entry, you'll put it back in the cache, it will evict another one, and so you're in a system which keeps adding and evicting stuff from the cache. While if you size your cache at 25, well, not only do you have your hot set always in memory, because you can hit these 20 elements, you even have space for these 5 extra entries that end up appearing once in a while and will be expired if they're not accessed anymore, so that you always will see them fresh enough when you come back there. But that's the kind of difference Aurelien was talking about. Like 15, 25, if you're at 20, huge difference. We mentioned consistency a number of times. Well, you want to be able to control that on the cache as well, which means you want to have a way to invalidate cache entries. So you should be able to remove stuff from the cache or clear cache. That's important in that context. Clearing the entirety of the cache probably indicates you've got some design issue there, because you should be able to be more precise, so invalidating on a per entry basis. But again, all use cases are not equal, and sometimes you may require like global invalidation of caches. The fourth item is a more personal addition, we would say. The idea is that the cache should not be the source of error in your application, since a cache can return null, or whatever if you've got an optional compliant API, or if you've got some boundary objects. And what that says is, sorry, I'm a cache. I don't know nothing about the mapping you're asking me. Please go ask your system of record. Since that is a valid answer. Since with eviction and expiry, when you put something to the cache can drop it on the floor immediately. For whatever reason, the cache could not be able to store the mapping you just added. Is it then an invalid cache? No. What's happening in the system may constrain the resources so that the cache fails to add the mapping. The good news is, from the outside, you've got no idea. Was it eviction? Was it expiry? You don't know. So it's not an illegal state. So why, if it fails to add or if it fails to retrieve, should you see an exception coming outside of the cache, breaking your application logic, when normally you've got exactly what you need in place to be able to say, oh, the get return null, I need to go see elsewhere. And so in that context, the cache should not be a source of error. No, don't get me wrong. The focus here is on the user's business logic being executed. You will have system where the cache malfunctioning will end up degrading performance so much that your application becomes unavailable, which in turn breaks functionality. But then that's a different case, because here the person you want to warn is not the user with a page 500 with a wonderful stack trace because you missed the error handler, but the person you want to see that are the ops guys, so that they can let you know, oh, something is happening with the application. For some reason, the cache is not working. We're getting a huge spike on the database, and we've got 20 minutes to act before everything falls down. But that's different. Again, it doesn't mean the cache created issues for users. It meant the cache not working creates issue for the maintenance team or the operational team.
Yeah, it's okay if you lose a user. I mean, it's okay. You can lose a user on your website because it took like 10 seconds to load the web page, but you cannot lose a user because the cache broke your web application. So really, if there's one thing to take away from this session is the cache should not break the functionality of your application. It's here to speed your application.
That's it for the theory. Questions so far, just in case? Cool. So, caching in Java. Who's heard about JSR 107? So that's a very old one, because I think Java 9 is like 390 something. Well, we'll come to that. But first, if you're in the Java world, good news is you've got plenty of caching libraries available to you. I'll mention ehcache or ehcache. No kidding. So Blazing Cache, Apache Ignite, Infinispan from the JBoss guy, Hazelcast, Google Guava couldn't find a logo. If someone knows that they have a logo, I'm interested. And others. I didn't put them all there. When you look on the web, pay attention to the date of the article, because you will find very old articles, and some of these libraries are no longer maintained. They probably have different Java version requirements. They have variation on the API. Some are at the limit of being a caching or a data grid for the case of Infinispan. I didn't put Redis in there, but Redis is also today a popular solution for doing caching. So plenty of options, and I'm just talking about the open source ones. There are also commercial version sometimes of these libraries. Both ehcache and Hazelcast have an enterprise version, but also pure enterprise versions such as Oracle Coherence. So, but the good news is JSR 107 brought a caching standard on the Java platform. So if you have a new application, you start development today, you have caching requirements that fit the features of JSR 107, I could not recommend more that you go with it. It will enable you to nearly seamlessly, again, you know the difference between completely seamlessly and nearly seamlessly, change providers underneath, if you stay in the limit of the features of the specification. So a bit of history. 107, Yel? 201. It was submitted. That's actually a few years before ehcache development started. Early draft, 2012. The JCP since then has changed the rule. You can't do that anymore. If your GSR stays dormant for long enough, it will get killed. But that was the past, so it happened. It was co-led by coherence and ehcache representatives. And they finalized the specification in March 24. So that's already 2 years, a bit more than 2 years. It specifies, and you'll see again the same terminology, emphasis is mine, specifies an API and semantics for temporary in-memory caching of Java objects, including object creation, shared access, pooling, invalidation, and consistency across JVMs. So it has also, it tried to take into account a large number of things. Let's go over a quick list of the features. The goal of the presentation is not to go deep into JSR 107. I think I did a number of them, and there are a number that you can find online. With the DevOps conferences publishing talks to YouTube, there is content if you're interested in these details. We start with a cache manager, which is a repository of caches. People who know the ehcache API will recognize its paternity. And on these caches, well, you've got expiry. That's a good news. You've got the integration bits, the cache loader and cache writer. We'll cover that in the pattern section. Cache listeners, if you want to listen on what's happening with cache mappings, honestly, think twice if you've got that requirement. I think at the JCache level, you've got two options. It's either synchronous or asynchronous. Think really, really hard if you realize that you need listeners synchronous, because this will probably have a cost on your implementation's performance. Entry processors. In Java 8 terms, you can pass a lambda that allows you to mutate the entry atomically and return a result. Annotations. Annotations in the context of JCache are not targeted at specification implementers. They're actually there so that frameworks can use them. So for example, Spring Framework allows you to use the JCache annotations, and then if you have a JCache provider, your caching will work, and so you no longer even have to depend on the Spring caching abstraction. And then, of course, some statistics and some JMX MBeans that you can use to see which caches are in your JVM and what kind of fit rate and percentage of get they have and stuff like that.
Yeah, that's really to help you to measure, because again, it's about measuring. Using cache is about measuring. It's not using it blindly. It's really trying to some settings, measuring, trying to improve, and then repeat.
What's missing? If you look back at if you remember, the desired cache features, it was the first bullet point.
Go back.
Yeah, capacity control, eviction. It's not there. It's not specified by JCache. So if you want to do capacity control with a JCache provider, you will have to go to provider-specific configuration. There is no way with the JCache API to limit the size of your cache. You can't do it. It's not part of the spec. So it's something you need to know. The way we resolve that in EHCache, we actually make sizing of your cache mandatory, except when you use GSR 107, then we will just say the size is max long in number of entries. Just think about the number of entries that makes, and if you really want that in your cache, in memory. But yeah, it's always the problems with specifications. Sometimes some concepts are hard to abstract properly, and so they end up falling out. On the API level, so that's the way you would get access to a cache. So the first thing you do is you've got a get caching provider static method, which will use the service loader of Java to find the single implementation on your class path. If there are multiple, this will throw. So you've got an alternate method that allows you to specify which implementation you want. It gives you a cache manager, which is, a caching provider, which is a repository of cache managers, where the cache managers are identified by their URI and their class loader. The specification also provides a default cache manager, which is the one I'm using in the second line, provider.getCacheManager. That's the default cache manager. So default URI, again, implementation specific, and default class loader, again, implementation specific. Once you've retrieved the cache manager, well, as said in the feature list, you've got a named cache repository, so you can ask for caches, cachemanager.getCache. And what the cache manager does is it handles the life cycle of these caches. So when you want to get rid of a cache, you can remove it from the cache manager. You can also close the cache manager, which will end up closing all the caches it uses, releasing all the resources, etc., etc. And then, of course, when you get the cache, you see immediately two types after the name of the cache. This is because, as you see on the left-hand side, you've got a cache of long string. And in order to enable implementers to verify the types you're giving, the types you want to use, you need to specify the classes, because you all know generics in Java erasure. If you just have the generic types on declarations themselves, nothing can be done at runtime. So that's why you've got to pass them when you want to retrieve a typed cache. There is a method that doesn't take the types, but then what usually happens is that the implementation underneath forces you to declare the cache as object-object. As soon as you specify the type of the cache, you can only retrieve it by that method, because that's the only way of having some kind of type safety. And so, what is a cache? It's a concurrent map sibling. So you'll have a number of basic operations, get, put, remove, a number of concurrent operations, put if absent, get and remove, and others like that. And in the end, all we've discussed above is configuration. What your application interacts with is the cache itself. And so that's what lives next to your business logic and is interacted with. The rest is really about setup and tear down of the application. What today leverages javax.cache? Well, Spring, the caching abstraction is JCache compatible since version 4.1. I think one thing can be said of the Spring guys. They're really jumping on the new stuff coming out. They made that available a few months after March 2014. So it's been there for a while. So that's really good. So, which means, again, in the Spring caching world, leverage that if you can. If your caching solution is JCache compliant, leverage that, then you can switch it. I mean, you already had a Spring caching abstraction, but here you can even go further. Hibernate 5.2, sorry, that's not what I wanted to do, released last week as a JCache module that the EHCache team contributed. And so that means that as of Hibernate 5.2, you can use all JCache provider as second-level cache. So that's a nice addition. And I think it's one of the ways you see open source working. We decided not to do an EHCache 3 integration, but rather do a JCache one, because then we have potentially also more people participating in its improvement and bug fixing, if any. Yeah. However, it does not include the transactional support that Hibernate second-level cache offers, for the good reason that JCache doesn't have transactional support. And so when you're talking to an API, you can only use what the API knows. More to come? Well, that's probably a call to participation. If caching is an interesting topic for you, you've got nothing to do of your evenings, weekends, or even have a boss who agrees to let you do that during the day. The Play Framework cache abstraction would be a perfect JCache enabled thing, because it's really basic. And other frameworks, Grails, I mean, could benefit from potentially a JCache integration. So think about it.
Application servers as well.
Well, that's Java EE, and that's a longer conversation. So I'm not going to go there. But yeah, JCache is not part of Java EE 8. The specification actually would require a number of changes to be fully Java EE compliant, which requires that a new GSR is started, which requires leads, effort, and for the moment, it's not really happening. For the moment, what's happening on JCache is there will soon be a release of a maintenance release that should mostly fix issues with the TCK. So the testing compatibility kit that providers have to pass in order to be able to claim that they implement the spec. So that's good. You've got what you need to do caching in Java. Great. But what exactly? Where should you cache? What should you cache? Guidelines. I guess that's the title of the slide. Who think it's a good idea to put mutable keys in a map? That's good. So don't do it. Use immutable keys for your cache. Remember, map, especially of the hash kind, will compute the hash code of the key, place the key then in a bucket based on that hash code, and then potentially follow up on equality if it's not unique. If you've got mutable content, which with a potential impact on the hash value, you may actually lose objects in the map, because the object will end up in a bucket which no longer matches its hash code, and so you may never be able to find it back.
It's really about remembering that the key is a reference to find back the value you want to put in the cache. So you shouldn't have to change it. You shouldn't have to do anything with it except using it as an ID like in database.
And we could nearly say the same of the values. favor immutable values. Don't put collections in a cache where the flexibility is left to the user to add and remove stuff from the collection, hoping it will update the cache. Because depending on the provider, and especially Jcache, you have by value and by ref semantics defined in the spec, by value being the default in Jcache, which means it will make a copy. So that will not work. On the other side, making a copy always has a cost. So if you don't need it, well, don't forget to configure your Jcache enable cache so that it's not using by value, but by ref. Also, you should understand what's your cache. Anyone? Oh yeah, it's great. I'm just going to put my Hibernate model in my cache. And then when I get it out and I access that lazy relationship, everything blows up. Sure. I mean, between the time you put stuff in the cache and you're reading it, your session is over, it's a different thread. I mean, if we talk distributed, you even had to try to serialize an Hibernate proxy identity. Don't do that. So think about what you're putting in the cache to make sure that it's not also, if you do like in-memory cache, and you end up pulling a whole bunch of companion objects that are injected by your framework or, you know, provide you some abstraction over what you do with your objects, well, they'll end up in the cache as well. Is this really what you want? And also, if it works on heap, when we'll discuss scaling, does it work as soon as you have serialization in there? And please, 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 I think we've said it a number of times, always account for a miss, whether it's due to expiry or eviction. If your application logic does return cache.get, this is no longer a cache. It just became a memory store.
Yeah, this is the complaint we always have. It's people who take cache, put something in it, try to read it, and then say, it's gone. Your cache doesn't work. No, it's normal. You should never count that the cache will hold the data you're trying to read. So the cache is not there to store the data. It's there to keep them temporarily to help speed your application up. Again.
On your developer workstation, if you're using Spring caching, think about replacing the cache with the no-op cache implementation. Your application should probably be as fast because you're on your development workstation, you don't have the full database and stuff, so it should probably be as fast, but it certainly must still work. If that's not the case, you're making assumptions that, again, in development, guess what? You've got, 5 entries in the cache? 2 threads accessing it in parallel? Indeed, when the cache is sized with 100, there will be no eviction. The expiry, you'll never hit it because you're not talking about nanoseconds level expiry. So it will work. And then under load, in production, well, stuff will start disappearing underneath you. Because guess what? You're no longer the only user. Hopefully. But then if you've got a single user application and you need caching, you've got a different problem. Need another session for that. So it's funny because, you know, in Java 1 2015, there was a bird of a feather session on trying to discuss what should be in the next Jcache version. And you've got plenty of things coming out. People want async caches, others want to really focus on adding transaction, others say we must have Java EE support because that's really important. And you've got all these advice that are all also triggered by the different features that the providers have, which makes sense. I mean, it would help if the feature you have becomes part of the specification, because then even more people can use your feature while still depending on the spec. There was one thing we all agreed with. If it can't be evicted, you're no longer in a cache use case. That, as caching provider, we agreed is the proper definition of a cache. So again, hitting the nail on the head, but remember. Don't get me wrong, it's not bad to have needs for an in-memory store or something like that. It's just don't go for a pure caching library then. And some libraries indeed are pretty much hybrid and will allow you to have versions where you don't have eviction, you don't have expiry and things like that. Or you have even memory store with expiry. So I'm not saying these products are bad, I'm just saying let's not call it caching then. let's go to some caching patterns. The first one, clear the cache and carry on. Who has an application with caching on that doesn't have a clear cache button on the operation console? Exactly. Okay, let's talk about cache aside. So that's the most frequent pattern you see. You've got your application, that red blurb on the bottom. You've got the cache, a nice cloud, because clouds are trendy. And you've got the evil database, the stuff from the 80s that you should no longer use. What happens when you're actually doing a miss? Remember terminology? Well, your application needs data. It goes to the cache. And the cache says, sorry, don't have it. So what you do, you go to the database. It takes a while. You get your answer. You don't forget to put it in the cache. And then finally, you're done. The user has his result. So at that point, well, you've paid the price of going to the database. The good news is, normally, you hope, locality of reference, you hope that someone soon will need the same data. And this time, you go to the cache, and you get back the data from the cache nearly immediately. Great, caching works. Okay, we can all go. Now, it's a bit more complicated than that, but let's see with code. You ready?
Yes. Okay. Yesterday there was...
So clearly I'm the manager, I do the slides. He's the developer, he does the code. Last time we did that at Devox Belgium.
Yeah, actually I'm a manager too, so
yeah,
don't give me orders. So yesterday evening there was a DevRocks party. I don't know if some of you have been there. They were having like 6 different beers on tap. I tested all of them, so please... I'm not going to be very fast, but okay. So we are going to do this demo using the Spring Pet Clinic application. So Spring Pet Clinic application is an example application to use Spring. It's a very straightforward application. So I'm going to start it to show you.
So the reason we do it with the Spring Pet Clinic application while it starts is that the application is probably basic enough that nobody should have problems following its business logic. And at the same time, it has a number of interesting characteristics which will allow us to go pretty far while discussing the different patterns and applying them concretely and showing you some of the issues you get with them.
Yeah. Okay. So you see, it's just like a web application when you have some owners and they have some pets and they go to the doctor. So just really simple database with some owners, and there are some pets, and you can edit the owners, you can edit the pets, and you've got the veterinarians. It's a complicated word. And yeah, really, it's a thing you will find 99% of the time. You have some data, you need to read them from the database, you need to insert them, change them, delete them. And the structure is really the straightforward Spring structure. So I guess you all know about Spring, but in case you didn't develop with Spring, it's a layering approach where you have the web part, which is a view, where the interaction part, and then according to the interaction of the user, the view part is going to call a service layer, and the service is going to do the business logic. So all the algorithm that needs to be done, like I want to find a list of owners, so I need to load them somewhere and list them back. And below there is a layer which is the repository layer, so the data access layer. So basically when I want to list the owners, as a user, I'm going to click on my button on the web page, and it's going to call the controller layer, which will call the service layer, saying, "Okay, I need all the owners." So it will call the repository layer, which will read from the database with a SQL query, and then return it back to the service layer, saying, "Hey, this is the list of owners," and then returning back to the view layer, and then displaying it on my browser.
So it's a long-winded way of saying that Spring is where you get hundreds of lines in each exception. Stack trace.
Yeah, well, like most of the Java frameworks, actually, but... Okay.
Don't say that.
So what Louis explained about the JCache standard is we have a JCache standard, which means that we need to have a jar because it's not part of the JDK. I'm going to look at the dependencies first to show you. So you need to have a dependency on javax.cache, which is the JCache API. And as Louis explained, so this is like the standard to be implemented by providers. So you have different providers, and you need to add the implementation. So this is, in our case, we're going to use the hcache implementation. So this is really those two jars you need to have in your application to be able to use JCache and its implementation. So let's have a look at the web application. So it starts there. It's really a simple application. So we define some beans in terms of Spring. It's some view of the different part of the application. And thing is, so we want to be able to use a cache. So we're going to do what was on the slide before: get cache provider. From this cache provider, get a cache manager, and from this cache manager, create some caches. And then we'll have some caches, and we will be able to use them inside of the application. So let's do that. We're going to create a cache manager. I'm going to slide a little. I hope you all see, because in the back, yeah, it's okay.
I'd add a few lines at the bottom so that you get higher.
Yeah. I'm going to try to stay at the top. Okay. So we want a cache manager, which are of the type javax.cache, which is a JCache. So manager. Okay. So first thing, doing like Louis showed, we get the cache provider, caching provider. Yeah, that's this one. And then we have a caching provider. Cool, seems to work. So we want cache manager. Let's take the cache manager. Get cache manager. So we want to be able to use some configuration, because it's like we showed, we indicated, it's you have different sets of configuration for cache manager. In the case of JCache, yeah, they are limited to what it can do. So you don't have to provide everything. We'll start with a very simple one, but let's create it. It's a mutable configuration. And so in our case, we're going to type it with a string and a collection.
So the string collection comes from what's on the service side, but we'll go look at the service when we wire in the cache. So trust us so far.
Yes. It's really it defines what you're going to put inside of your cache. And we're going to put in our caches collections of objects, and the keys will be strings. Okay, immutable configuration, and I think that's it. And we need to do set type, right? Yeah.
So here, what Aurelien is typing, if you see the mutable configuration accepted no argument constructor except for a copy constructor, which means that the key type and the value type that are specified as generic bounds can't be used at runtime. And so you really need to call configuration.setTypes, because otherwise, even though you're using it as a mutable configuration of string collection, internally it contains object and object as the two types, which means stuff will break sooner or later. So remember, always call that. You need to create a cache manager variable, line 70. You forgot that.
Ah, yes. Yeah, I was waiting that you were done. Okay. So we create the cache now. So we're going to try to cache the owners.
Search.
Yeah. Yeah, okay. Search. Let's call it like this, and let's use our configuration. So what I'm going to cache is this part of this application. It's when I find owners, I put a name, or I put nothing, and it's going to execute some SQL to load the owners from the database. So here is the logging of the different SQL queries. So I'm going to clear my screen, and you see if I try to find the owners, yeah, there's a bunch of SQL queries, so a bunch of access to the database. And we want to cache that so we don't have to access the database, and indeed we go faster. So this is why I call the cache owners search, because it's related to the fact that I search for owners. Okay, so I created my cache, so I can return my cache manager. So exactly like we said, the cache manager is a repository of caches. And now, when I will get my cache manager instance, I will be able to retrieve the cache I created. So of course I could create several caches, and now I'm going to create one just for this case. And then we go into the application. I'm going to remove this one. Okay, so like I said, there is a service layer which is doing the logic. So again, yeah, trust us. To the part which called the database to get all the owners is this method name. Yeah, it's this one. So it's find owner by last name. So it's what I put in the box. And you see it's calling the repository, so basically the repositories, and it translates into SQL queries to retrieve the list of owners, because of course the last name, you can have several owners with the same last name, so it's this is why it returns a collection of owners. So this is where I'm going to use my cache. So this is Spring. This, in case you don't know about dependency injection, really the strongest point of Spring dependency injection is to be able to inject instances of objects inside your classes, rather than you have to instantiate yourself an object inside of your classes. So here is going to inject my cache manager, yeah, and in my constructor, and so I'm going to be able from this to get my cache. So it was owners search, and it was string type for the keys and collection for the values. Cool. I'm going to keep a reference to my cache on a search. Okay, let's name it on a search cache. Okay, so now in my service layer, I've got access to my cache. Great, so let's use it. So here, instead of calling the database every time, I'm going to do implement the cache side pattern that we explained. So I'm looking inside of my cache. I get from the key is the last name. So I get from the last name what is the collection. Okay, so let's make a variable from that. So I look inside. I get with the key, which is the last name. I get the collection of owners in the cache. is it in the cache? If it's not null, if it's in the cache, then I can return it. Oh, I didn't type my cache. Yeah, no, it's okay.
Yeah,
it's unchecked because I didn't type it. Yeah.
So again, that's the problem. So yes, caches are generic. Yes, you can specify the key and the value types, but you realize that as soon as these types are generic themselves, you're stuck because of erasure. Yes. There is no way in Java at the cache level to tell it, oh, this is going to be a collection of owners. You can only tell it, this is going to be a collection. That's just standard generics limitation, and no, there is no magic to figure it out. No. So,
okay, so if we found the collection of owners for a specific last name in our cache, we return it, and that's done. Don't need to do anything further. Great. If not, we're going to have to search inside of the database. So we're going to do the actual business logic to get the collection of owners. And then we'll put it in the cache. So owner search cache. So next time I call this method, it will be available in the cache. So I put my owners for my last name, and then I return it. And that's it. Let's try to see if it works. Should, I think.
So at one point, I don't know if you saw it, but Aurelien deleted at enable caching. We haven't completely figured it out, but if you do it manually, like he's doing it, and you have at enable caching enabled, it will just tell you that there is no cache manager bin.
Yeah, it
whether you use the javax.cache cache manager or the org.cache cache manager, for some reason, it just blindly refuses to create anything. We don't know why, but yeah, so that's why you remove that. For the moment.
And actually, this has nothing to do with JCache. This is something related to Spring, so it's out of scope of this discussion. So, I mean, just ignore it. Okay, let me try to put that up. So you see in the logging that, yeah, my cache manager is created with a cache. Cool. So it should work. Let's clear. Done. Okay. I try again. Sorry. Okay. So I'm going to find the owners. I'm going to do a query with nothing in it. And you see, oh, cool.
Yeah. So I said nothing. We stopped when we prepared that just before then.
Yeah.
So what happened here? If someone remembers one of the defaults of JCache, it's by value. In the Spring Pet Clinic application, the owners are not serializable. So that's the problem. So you just need on the... No. Don't do that on the owner.
What?
Go to the Pet Clinic application where you configure the cache. And just on the mutable configuration, call set after set types.
Okay. You want to put it, okay.
By ref.
Set, which one is it?
Store by value false.
Store by value false, yes, that's this one. Which is funny because we didn't do that. We didn't do that.
No, but I know about that one. That's one of the gotchas of JCache.
Okay. Cool, so we can start again. Let's clear the screen. Oh, I'm too fast. Oh yeah, it's created. Okay, so I'm looking for my owners, and in my terminal I see a bunch of SQL queries to load the owners. Going to clear my terminal, and now for the same query, it shouldn't try to read again from the database because it's in the cache. So I get my owners, and indeed I don't see my SQL queries anymore. It's not logged anymore because it's in the cache. So really, you see, it's quite straightforward to use the cache aside pattern. You try to get something, it's not there. You go to search it where it's there. You put it in the cache, and so next time you take it from the cache, it's in the cache. The problem with this kind of pattern, one is you have to do a lot of code, and imagine that it's always the same thing. You have to repeat a lot of the same code for all the caches. Every time you're going to try to use your cache, repeat I searched into the cache. Is it there? Not. So it's really a lot of repetition. And second thing is regarding concurrency. When you have several processes, several threads, several users trying to do the same thing at the same time. Imagine you have two users who are searching for the same query. They enter this method almost at the same time. So the first one look inside of the cache, and it's not there. So what it's going to do is going to call the database. But before it has called the database, the second user enter and look in the cache. Oh, it's not there. So I'm going to call the database. Oh, but at this point, the first one has already called the database and has put the result in the cache. So actually, it's in the cache. But the second user is going to call the database anyway. So you have a cache, and it wasn't useful for you. So of course, you can do some synchronization to make sure that two different threads are not going to do the same call. But then you have a blocking point, and then you lose some performance. And the point of using cache is performance. So yeah, it's very easy to understand, very easy to implement, but yeah, it's not the best pattern to use. I think that's it for the demo.
So I'm going to take over just a bit to show you what happens if you start using a little bit the EHCache 3 API as a way of doing, for example, first of all, resource control, so that you can size your cache properly. And then we're going to see that the way we did it here was educational. But let's be fair, the Spring Boot guys did a great job. And so I'll show you how you get rid of most of the code we wrote and just do it differently. So first of all, I'm going to go back to the pet clinic application. And instead of using that configuration, I'm going to go provider specific. So I'm going to use a new cache configuration builder, which is the Fluent interface that EHCache provides to configure caches. And what I need to do here is the usual string.class, collection.class, and then I want to size my cache. I'm going to say it's a heap cache with 100 entries. So static import, because that's the whole point of Fluent API, otherwise it's not really readable. And let's say to demonstrate something else that I want some expiry, so I'm going to go with an expiry that's going to be a time to leave expiry. Sorry. There you go. Time to leave expiration of 60 seconds. Sorry for the screen. Yeah, there. So you see, so now I got my configuration EHCache style. And the good news is it's pretty easy to integrate it here because I can just do from EHCache cache configuration, again, static import of that config, and that's it. I've wrapped my EHCache specific configuration into a type which GSR 107 understands, and of course, internally, we re-extract it so that we can build the proper full-blown EHCache cache. So if you pass the config we just gave you to another provider, it will still do some configuration of the cache, like the key type and the value type will be respected, and then you will get what EHCache thinks are the proper defaults for the rest, meaning that the by value will be false, it will be by ref, because we believe on heap that's what makes sense. And so here, I've just done that, okay? I'm not gonna restart the application, it should work. I don't want to tempt fate, it may fail for some weird reasons, but that's honestly the way you would do it. Now, let's be honest, if you're using Spring Boot, forget about that.
Yeah, just one thing I want to emphasize again, because in case you're a bit confused, so really you have the JSR 107 standard, which JCache, which defines some API, and we implemented that in AEH cache. But because we have many more functionalities that goes beyond JCache, we also give the possibility to create an EHCache config with those extra functionality like sizing. But because we implement the JCache standard, you can configure an EHCache configuration with all the extra feature and then get a JCache configuration. And that's what he did.
Yeah.
Because it's a JCache provider. So you need to give a JCache configuration, not an EHCache configuration.
So I got rid of everything. I just put back the enable caching annotation. I'm going to go to that method, revert it to the way it was, and add at cacheable value owners search. Okay. Then what I do next is I go to my application.properties. I use the IDE, which provides me the Spring Cache JCache config param. Okay. And now I just need to make sure I have that file available. So EHCache 3 uses a really EHCache 2 was like you had an XSD to help in your IDE. Here we actually validate with the XSD. So it's a much stricter schema-based thing. So what we need is that owner's cache. Sorry. One change. I'm not allowed to specify the key and the value type. I'll show why in a minute. So I'll leave it like that. I specify the expiry. We set TTL. 60 seconds should be the default, and I do heap, and that's it. I'm back to where I was with a cache configured using the XML format of EHCache, and all the wiring happens automatically. So let me Control-C that, restart. That change I'm taking, it should work. Oh yeah, you see us doing Maven clean if you've looked at the quick sentence. It's because actually not doing Maven clean beat us at one point while preparing the demo, so we decided, let's do it. You should not always need it, but still. So that's it. If I go back to my application, refresh that, something happened, of course. What did happen? It should have worked. Owner's search. Cannot find cache named owner's search. Did I do a typo between the two? Yeah, sure. I called it owner's cache. So you see, it's not. It's actually really working, meaning that it shows you when it doesn't work. I guess Aurelien and I don't have the same naming conventions. That's not me, that's just that the site can be reached. What? Again? Whoa. Okay, I was not expecting that. So they actually use the key type when they can determine it from the signature of the method. That's interesting. Sorry about that. I just want to show you that the kind of wins you get from Spring Boot. Okay, I'll stop there.
So you understand now why we were saying a cache shouldn't make your application fail, because otherwise it's really terrible.
So for some reason it was complaining because I did not specify the key type, but now that I'm specifying the key type, it says that it doesn't get the cache with the proper key and value type. So this is a limitation. I'll have a look deeper because if it's really broken like that, we need to talk with the Spring guys to find a way to fix it. But so that would be the way of getting everything like auto-wired. And was there anything else? Yeah. So like I mentioned, a minor issue you have with if you've got a cache manager, which is a JCache cache manager, on the cache itself, you can get a cache with the class signature. You can get a cache with just its name. You can get the cache names, but you don't have a way to get to the configuration of the caches in order to discover the key type and the value type they declared. So you're limited in introspection. That's sadly an oversight, and again, it's a spec. It's not easy to change because adding anything means you're breaking the spec, because if an interface gains a new value, this is Java 6, no default implementation, so we have to go change everything to all the providers, so that's a problem. EHCache has a way of doing that because you can actually interrogate the cache manager to get the cache configurations. And so you can find which name, key type, value type, and then you can do the get cache with the key and the value types. So that's it for the demo. Let me switch back there. That's really working cool. It's so much better than having to switch between the computers, mirroring and non-mirroring and stuff. I believe there is a break like around 4, so we might be a few minutes early, but you'll have your coffee break. So wanted to have a quick slide on Hibernate second-level cache, which I learned a lot more recently by helping that JCache provider. So you remember I told you don't do crazy stuff? Well, we were actually storing Hibernate entities. So we're on a single machine doing everything closely related. It works pretty well because there is no lazy stuff, etc. But the way Hibernate solves that is that you get dehydrated entities when you use Hibernate second-level cache. So it's a flattened version of your object. View it as an array of properties rather than a full object. And also, Hibernate, while it's a cache-aside implementation, has a whole lot more strategies where they will go beyond the simple code we show in order to provide enhanced consistency. And for example, the first thing is read-only. Well, it's very clear. If you declare that your entity is read-only and you cache it in a read-only region, as soon as you try to mutate the entity, it will blow up. Clearly letting you know, you've told me it's read-only, which means I'll cache it forever and never go back to the database. Well, then I can't allow you to mutate. So you can create, you can get, but you can't mutate. You can't update. Non-strict read-write. You've got read-write semantics, but you don't want them to be strict, which means that there are windows of opportunity for seeing stale values. You have to deal with it. Read-write. So there, the way it works is when, for example, you do a remove, you will actually leave something in the cache, which is a sentinel value that will prevent any other transaction from populating back that mapping if the transaction started before the current transaction finishes. So the transaction that removes kind of identifies this entry can only be replaced by a proper cached value if you started your transaction after mine so that I know you view what I committed. And so this is, for example, the kind of thing, if you think about it, doing cache aside will potentially give you that problem in your application. There is a race, a potential race. Hibernate solves it. Should you solve that in all your applications? Probably not. We'll see also that patterns, more advanced patterns can help. And of course, you've got the transactional region, which, like I said, is the one that's not supported with the JCache provider because JCache is not transactional. I mean, has no transactional support.
But Hibernate, in case you don't know very well, because maybe you have not used it in depth, but so Hibernate has 2 levels of cache. One is internal, the first level, and second is a pluggable cache. So EHCache historically was the main provider for Hibernate second level cache. Originally, EHCache is Easy Hibernate Cache. And so the thing is, what we've seen in the cache side, where you say, okay, I look inside of the data, I do the SQL query, I get the data. If it's not there, I put it in the cache. What Hibernate does is way more complicated. So it's more elaborate to use the cache to give back the data as fastest as possible. So this is why there are all those different modes.
If you're using Hibernate and need a data level cache, use theirs instead of rolling your own on top, because you have large chances of shooting yourself in the foot. So summary on that whole cache side. Well, first of all, it's the solution most seen out there. Spring, Play, Grails framework. Most of the framework do enable to do that. Why? But you've seen it. Instead of having to write that wrapping code around a single business method, you can use annotations, because this is really an around aspect. The whole caching thing, the whole logic Aurelien described and coded is completely agnostic of what the business thing is doing. It's really about, do I know the result already? No. Compute the result, store the result, return the result. Do I know the result already? Yes, return the result. Nowhere do you need to know what computing the result exactly means. However, tricky to get right. Concurrency, Aurelien described the problem. Atomicity, I described why Hibernate has evolved more complicated strategies. And especially when you roll your own. I mean, who never had a concurrency related issue? That's good. Did you ever wrote concurrent code? No, but I mean, concurrency is clearly one of the places where you'd like to leverage the existing environment, whether it's an application server providing you some kind of isolation or using proper libraries for that. And it's the thundering herd problem is the problem Aurelien described. When your cache is cold and the application starts up and you've got potentially your first 100,000 users connecting all at the same time and all your reference data is not cached, well, you may end up fetching that data 1,000 of times before it finally is in the cache and all the subsequent requests see it and stop loading it. Yeah.
Actually, inside of the annotation-based approach, there is no synchronization at all.
Nope. No, they can't. They shouldn't do that.
Yeah, sure.
No. There is no synchronization. So it's really the race you saw Aurelien explain is exactly the same race you'll find in the aspect that Spring implements and others. And Hibernate, like I said, does more than that, but that's also because it stores internal stuff. And so, yeah, no, there is no. Otherwise, you're defeating the purpose for caching.
The break is at 4, right?
Yeah, the break is at 4.
Maybe
so
we're not going to go further because
next thing will be cache through,
yeah,
and we'll do that after the break. Please come back.
Yeah, and if you have a question already,
yeah, you can come talk to us during the break, no problem. Let's go back and continue with the more advanced caching patterns. So the next one is what we call cache through, and the difference, as represented graphically, is that the application is on the left and not the bottom. No, it's that the cache sits between the application and the database. And so in that pattern, what you do is you no longer access the application, the database from your application, you actually go through the cache, hence the name. So if I read and it's a miss, the cache is empty, has no mapping, it's the cache itself that goes fetch the mapping from the database, populates the cache, and returns control to the application. You see immediately that if your caching provider is smart, you've resolved the thundering herd problem, because what will happen in that case, when you're warming up your cache, only one thread will actually go to the database, all the others will be blocked, waiting on that mapping to appear in the cache, and then control is returned. Blocking is bad, sure, I agree, but is blocking worse than going 10 times to the database when only one is enough? Well, I think it makes sense in that context.
Yeah, cache free is really about moving the responsibility of handling the caching of the data, of pulling and retrieving the data in your cache. moving this responsibility from you, like we've shown, to the cache loader or cache writer. So, like we said, if the cache implementation is good, it's going to optimize all those blocking problems, and it will give you the best performance to have both, like, the security that you're not going to do the call several times, and at the same time, not going to block your application for too much.
Yeah. And of course, aside from the thundering herd problem, a number of these concurrency issues are resolved for you because they're handled by the cache. So if you move to the heat, well, it's pretty easy because the heat in cache aside and the heat in cache through are pretty much the same thing. You go to the cache has the content, it returns it. And it's done. What happens when you do a write? Well, what happens is that you're putting something in the cache. Well, it's actually the cache taking care of writing to the database. So again, cache is really a transparent proxy on top of your database. Does it work? Let's see.
So if you remember one of the previous slides that we showed, it talked about cache loader, cache writer as one integration point with the JCache. So we are using this separate entity called cache loader writer, which is going to take care of doing what it needs to retrieve the data, so like reading the data from the database. And then the cache will handle the cache loader writer to get the data in case it doesn't have the data in cache. So we're going to need to write a new class, which is a cache loader writer. Do we talk about the cache loader writer choice now, or?
Yeah, I'll quickly cover that. You should switch to presentation mode.
Okay.
So in GSR 107, the loader and the writer are two separated concepts. In EHCache 3, we've merged them into a single one. The reason is that we want you developers to think about what you're doing when you do a cache which is read-through only. Because we can't prevent you from putting to the cache. But if you define the cache as read-through only, meaning you will not write to the database, anytime you write directly to the cache, you're most likely putting your cache out of sync with your database. And you're smart people. If you do that, you know why you're doing it. But by having a unified interface, we want to make sure you actually think about it. And potentially, you want to throw an exception because it's strictly disallowed to write to the cache, and at least that's something you can find out in development while you're actually developing the application. Or maybe indeed, you've got different types in the same cache, and some of these types can be written, and so what you just do in your loader writer is ignore all the writes. But we wanted the responsibility to be yours, rather than offering you a pattern which is half-baked. Like just read through without having decided what happens to the writes seems wrong.
Okay, so I'm going to create a new class, which will be a owner search loader writer. Let's call it like this. And this class is going to is going to implement a cache loader writer. Loader writer, yes. So here I still have my string and collection types, since it's a string as a key and collection as values, collection of owners. And then I'm going to implement the methods of my interface. Just a quick review of the different methods. We have load all, write all, delete all. So we say that a cache was a sibling of the concurrent hash map. So for the CRUD operation, in a cache you have put, get, and remove. Pretty obvious. So when you're going to do a get in the cache, if it doesn't find the value in the cache, it's going to load it from the cache loader writer. So you're going to implement in the load the business logics that load the data from data store or compute the data. I mean, whatever business logic is there, you're going to put that inside of the load method. When you do put, you're going to do write, and when you do remove, you're going to do delete. Then you have some bulk operation, so to do the same thing, but with a number of values at the same time. So, okay, let's implement. So I'm not going to implement everything. In our case, so if you remember, I'm looking at the find owners. So I'm going to do the load. I'm going to see to get the data from the database in case I want to do a get from the cache. So I go back in my service where I have, okay, is it in my cache? Yes, I return what's in the cache. It's not in my cache. I get it from the repository. So I do my SQL queries. So this is this part. I'm going to move to my cache loader writer. So it's a collection of owners. Oops, like this. And I'm going to return. Okay, so here I need, so here the last name is the key. So last name. And I need the owner repository, so I'm going to add it there. Owner repository. So it's Spring, so it's pretty cool because you have dependency injection. So I just need to add a Spring annotation to say, okay, Spring, please inject the owner repository instance in my loader writer. So really, that's all. The loader writer will be executed only if the value is not in the cache for the given key. So if it's not in the cache, I go fetch it on the database, and then the cache will return it from the loader writer and will insert it in the cache. So next time you get it. So next, let's do some cleaning. So like I said, now I don't have to worry about testing if it's in the cache or not. I'm just going to get it from the cache and return it. And the rest is not my concern.
So notice once more, what we're doing here is we're actually just looking inside the cache. The reason we can do that is because we know that the cache is the entity responsible of looking into the database. Otherwise, again, we're no longer considering it really as a cache. The reason this code is good, it's because we know the cache does more by being integrated.
So of course, I need to tell to my cache that it has a cache loader writer and it should use it. So it's in the configuration. So that should be fair, right? Well, sorry, with.
You're inside the, you need to be outside the parentheses.
Oh yeah, with loader writer. And then I'm going to use my cache loader writer. So of course I'm going to need an instance of it. So it's my owner search loader writer. And I think it's with auto-wired it should Okay, so as a service. Yeah, I didn't declare it as a service. Yes, I know that one now.
We're probably abusing the service annotation and stuff like that to get the wiring done. Again, this is not a Spring presentation.
Yes.
This is a caching.
Yes, if you find a mistake in the Spring configuration, okay, you can don't blame us. We're really focusing on the caching concept here. Okay, so I have owner search loader writer. I said to my cache, hey, use it. And then my owner search loader writer knows that he has to get the data from the database with the repository service, and my service just look inside of the cache. So everything should be good, hopefully. So you see the refactoring makes it really more elegant, because instead of having those test and conditional branching, you just are reading the cache in the service because you expect it's in the cache, and then you put the business logic in the loader writer, and it's all separated. It's all very clean. And that's now that we're going to test. So, okay, I'm trying to look at the owners. It's not in the cache, so it has done the SQL queries. I'm trying again. Oh, sorry, I should clear the cache. Trying again. And it's not showing the SQL queries. So it worked, actually.
Yeah?
Yeah, I'm surprised. I was expecting some kind of errors. It's too easy. Okay, so I think that's it about the cache loader writer.
Yeah, so we're going to do the loading part, and we'll talk about the writing
later
in a minute.
Yeah, sure. Yeah, again, yes, of course, you shouldn't implement something in all method, even if it's to throw an exception, like we indicated that you explicitly doesn't want your loader writer to do anything in case of a put to the cache or a remove. So, but yeah, it was just for the example. So we'll do the write in the next step of the demo.
So that's it for cache through. Pretty cool. Although, let's be honest, it's most often gonna require that you evolve the abstraction and the modeling you were doing. Because I don't know if you've looked at the parameters of this cache loader writer method, and they're pretty similar to the JCache one. You get the key and the value, or the key. That's about it. So it means you need to be able to do all your data interactions from these types. And depending on the way you store stuff in the application versus the way they're stored in the database, it may not be as easy. The good news is we took a pretty easy application to show you it's possible. But it's also a bit of, fairy dust. It probably won't be that easy in your complex business application, but if you can do it, even in a number of places, it's probably helpful. Reduces the code, reduces some of the complicated things that cache aside, some of the downsides of cache aside, but it has an impact on your modeling.
Yeah. The thing is really, it's really a good indicator on how well your application is structured. If it becomes like a hell to implement this pattern, it means that your code may be not well. The architecture of your code maybe not right, or stuff are like a bit mixed. Because you see, when the code is clearly defined, like this layered approach, it's very easy. There's no problem.
So, like we said, viewing the system. Of course, what you win are the better guarantees and consistencies. Especially, invalidation is no longer a problem. You don't have to take care of invalidation anymore because all the interactions happen through the cache itself. So you're guaranteed that your cache is always up to date. That is, unless you've got an external system that goes into your database and do changes. That pattern doesn't protect you against that. If that's what you have in your application, you'll still leave an external triggered invalidation just to tell the cache, you know what? I know you're syncing everything, but this time we changed the data from elsewhere, and please forget about anything you have in memory and start reading stuff from the database again. Now, there is one thing which we didn't illustrate right now, but if you think about it in the way I described the process of a write, the thread putting in the cache is the one paying the price to write to the database. Wasn't the cache supposed to, by using more memory, make you gain latency? Well, in that case, you're not only using more memory, but you're still paying the same latency with that thread when you write. Well, if you're honest, in a cache-aside pattern, you still have the same problem. Because even though you're not writing through the cache, your thread at one point needs to write to the database. But the benefit of using cache through is that you can go one step beyond. And you can start looking into write behind. And what you do with write behind is you've got the application, the cache, and the database, but look that we introduce a queue. When we put something in the cache, it doesn't go to the database. It just goes to the queue. That's one item. You can have, that's it. Your interaction with the cache is over. Control is returned to the application can proceed. In parallel, other threads are adding stuff to the queue. This is, for example, in case of batching. The queue will wait for a bit. You can even coalesce, meaning that you decide that all these mutations for the same key, I should just keep the last one. It's good enough that K1 moved to value 1, then value 2, then value 3. I only need K1 value 3 in the database. Of course, it could be that your application actually has auditing requirements so that you want to see all the changes. Well, no problem. Just don't enable coalescing. So you will write everything. And then what happens is that after a while, asynchronously, the writes get sent to the database. Now, when you do that, of course, you stop paying the price of the write on the cache interactions, but you increase some of the complexity. Because suddenly you've got asynchronicity between the moment something happens in your application and it gets released to the database. Is it something you can live with? Well, that depends on your application and your business needs. And so that's really right behind. And so we're going to go back to the demo stand in order to show you that configuration-wise, it's just a bit more. Don't forget to switch to the branch.
We start first by implementing the...
So it's going to switch to a different branch where what we've done is, so we showed you loader, cache loader on the find owner. And here we're going to switch to a place where we've already wired a loader writer, but for the moment where we create an owner. Because we're looking less into the read bit, but more into the write bit for the moment of cache through.
Yeah, so we have this, so we have really, so it's like we said, we have two loader writer at this point. One is returning a collection of owners. So it's for the search call, which is searching and returning a collection of owners. And
you want to close the menu, because otherwise it's...
And the other one, the other loader writer is for loader writer, yeah, is to it's about a single owner, because when you're going to save an owner, when you're going to insert an owner, you're not going to insert a collection of owners, but just a single one. So this is why we have these two owners. And so you see here, to implement the write, so maybe I should go inside of the in the service. So the save owners, it used to have this line. It used to be like this. When I want to insert an owner, I'm going to ask to the repository to save it. And the repository is going to do the bunch of SQL queries to insert it in the database. So now, because we have the loader writer associated to the cache, we just do a put to the cache. And we use the last name as a key and the owner as a value. So did we? Yeah, so I go back to the application. So you remember I had created this owner search loader writer that I had added to the cache. And now what I have is my owner loader writer for my single owner that I added to another cache.
You need to change the config. Remember, you're not using owner config.
Ah, yes.
Line 99.
Yes, that one. Owner config, yes. So you see, really, it's really not very different from what we've seen before. It's just that in a case, when I do a search, I have a collection, so I'm going to put it in a different cache. And when I want to do a write, or even if I wanted to do a read of a single owner, I would use a owner's cache, which is the single owner's cache. So you can create many caches according to your different use cases. I could create, of course, cache for the pets, for the vets, for anything. So I think we can test this before adding the write behind. So
I think you want to make sure the write is done.
The write is done?
In the loader writer. Oh yeah. And so what we've added is a thread sleep 5 seconds because it's funny to be slow.
Yes.
It's the way we simulate the latency you get with your database. And so indeed, that's what we're going to demo first.
Yes. So do you want to do the refresh thing after? Yeah, no?
Let's do that after.
Okay.
Let's do it for the moment.
So we have a slow call to the database, or it could be some slow business logic to write what ends up in the database. It's slow. So let's start it. And we're going to insert an owner. So I've got my caches. One is the owner's search, and the other is the owners. So again, it's in order to make it clear, if I search for owners, I'm going to get a collection of owners. So this goes inside of the owner's search cache, which for last name will hold a collection of owners. Now, if I want to insert an owner, add owner. So let's insert myself. Okay. If you want to call me, that's my phone number. Or if you want to send me a card.
You realize that goes on YouTube, though.
Cool. I'm going to have a lot of calls in the middle of the night. So I'm going to add an owner, but here it's a single owner, so it's going to use the owner cache. And so it's going to use the owner loader writer, which is going to do the write method to write inside of the cache, of the repository, sorry. So I'm adding myself, and it takes 5 seconds. Yeah, it's a very slow call. Oh, finally I got it. So you see, when you've got this kind of slow call, it's when you might want to do some asynchronous call to the database. And this is when the write behind is really a good candidate. Because instead of waiting that the database completes the call, you're just going to say to the cache, okay, just write after, just return immediately so I can continue to do what I want to do in the application. And then the cache loader writer will write it after. And so even if it's slow, you don't care because it's not going to impact the application. The application is going to be very fast. Okay, so let's add the write behind configuration. And you see it's going to be very complicated because I just need to add write behind configuration. So we have some builders in EHCache to do some to help writing the configuration. It's batched, and then we're going to put a delay like 3 seconds. Seconds, and let's say we have a batch size, so it means when there are 5 values to write, it's going to batch them together.
And if the batch isn't full, it's going to wait at most 3 seconds before writing an incomplete batch.
Yes. So that's it. I've added my write behind configuration, so my loader writer knows that no, yeah, it has to write behind.
This utility comes from EH cache or from JCache?
No, that's cache this time, yes. Right,
Yes.
the write behind is not part of the specification.
Yes.
But if you think about it, what we're showing you is that it didn't change his loader writer. So, because cache does it for you, but if you want to do write behind in JCache, the only thing you need to do is make sure your loader writer implementation does asynchronous interactions with the database. Then it becomes your responsibility to implement it.
Yes, in cache we do that for you. We do the write behind stuff for you. Okay, so I started my application. I've got my caches, and then I'm going to add an owner, and it should go very fast because it should return immediately. And then it will be returned behind by the loader writer. Oh, something happened. Damn, what happened? Yeah, I know, yeah. That's the next step of the demo.
So we can explain what happened.
Yes.
So did you remember what happened when we were synchronous? It would immediately show us the view of the owner.
Yes.
Guess what's happening now? It doesn't exist yet.
Yes.
So it can't show it immediately because we're creating it asynchronously. So we'll see why exactly. We'll just finish on the showing you that the owner actually made it. If you search them.
Yes, you can find them. Let's look for myself. Oh, I'm not there.
Again, why is that?
I don't know. Oh, maybe it's something with batch.
So
Yeah.
which method did he implement in the loader writer? The write method, exactly, the single one. But he's using batching. Guess what?
Batching.
Write all is getting called.
Yes.
So for the moment, we're throwing everything on the floor.
Yeah, we're doing nothing.
It's asynchronous and really, really, really fast.
So there is a batch write behind configuration, but there is also an unbatch. How is it called? Unbatch. There is yeah, that one. There.
This piece of configuration technically only matches with the write all.
Yes, because you're asking for batching, so everything will be batched on the right side. So it will only use write all and delete all and remove, delete. I can't remember, but that one. Yeah.
Yeah.
So we're doing a very efficient batch implementation, as you can see.
Yes.
Anyway, the single ones will still go directly to the database without any.
No, because the batch, it's
Yeah, but imagine that you've got a big value to be stored. Yeah? It still makes sense to put it on the queuing and do it behind the scenes, right? To save time and to.
Oh, sure, yeah. So, but what you can do is indeed what he showed is that you can decide that you don't want the batching.
Yes. You have
You really want each time you get a put, you really want that put to be put on the queue to be processed as soon as possible.
Yeah. So here I'm just iterating through my collection, so through my batch, and then I'm just calling the write method.
Okay.
So.
You've got one parenthesis too many at the beginning, I believe.
Why is there? It's weird. Anyway, so yeah, I'm just going to write the database, and then we can try to see if it works and if I'm inserting myself into the database. Okay, let's start. Let's wait till it started. Okay. So again, I'm going to add an owner. It's going to fail because of the way the application is structured.
We'll get back to that in a minute.
But that time, I should be there. Yes, cool. So it worked. So really, it's you see that doing this write behind configuration is really easy. Again, it's straightforward, and it's really up to you to decide, okay, do I want to do it now or do I want to do it later? But at least you see that now, because it's done after, it's right behind, it's not blocking on the long operation of saving the data in the database. So it's a really quick way to solve my blocking problem. But it has a cost, and in this case, the cost is that I'm going to have to choose about how I design my application. I'm going to show you what's happening in this application. So it's the controller, and it's this one, yes. So, like we indicated, what happens is when you insert, no, that's not that one. Yes, yeah, when you insert a new owner, so this is the URL, what it's going to do is it's going to save the owner, and because saving the owner is going to insert in the database is going to assign an ID to the owner. So maybe we can have a quick look at the owner. So there should be an ID somewhere.
It's a person.
Sorry?
It's a person. So
it's in the person, okay. First name, last name, no.
It's actually a base entity.
Ah, yeah, that's why.
Inheritance for the win.
Yes. Yeah, that's... So the thing is, it gets the ID from the database. So when you save the owner, it's going to update the object with the ID it gets from the database. And then it redirects the page to /owner/ the ID you just got from the database. And like we indicated, now that we're doing a write behind, when it saves the owner, so when it does what we change, which is to put in the cache loader in the cache, which is going to delegate to the cache loader writer to write behind the data in the database, it's not going to get an ID because it's not written to the database yet. But it's going to do a redirect immediately after and trying to get the ID, which is null because it hasn't been assigned to the database since it hasn't been written to the database. And this is why we've got, when we're inserting, when we've got this something happen, which is the exception of saying, okay, there's a null value, and the null value is the owner get ID. So at this point, I've got to choose. I know that I've solved my performance issue. It takes 5 seconds to write in the database. I don't care. It's written behind, so it doesn't block my application. But because it's not written, I don't have the ID. So either I have to change the behavior of my application and say, okay, when I save the owner, I'm not going to show it immediately. I'm just going to redirect to some generic page like find, the find page. So that's one way. But of course, the people who are deciding of the design of your application, they may not be happy with that. So the other, if they say no, we want that it shows the owners after you've saved it, you're going to have to change your code. And in that case, you're going to have to take the responsibility of generating the ID instead of delegating it to the database. Which means that in your business logic, before saving in the repository, you're going to have to generate an ID. And when it saves in the database, you're going to use that ID to insert in the row in the SQL query.
And of course, the generation of that ID, I mean, it's not like you have to generate a UUID or anything. It could simply be that your entity actually has a natural ID that you can use. Here, clearly, for the moment, you've seen us use last name. This is not production ready. Don't assume last name unicity in the world. But something else could be unique. Something that then doesn't need to be database generated. And then what you need to do is do the proper modification so that you use that indeed not only as the database key, but also as the cache key, and then you can get everything. I mean, after all, we went through the cache. That owner is in the cache.
Yes.
We don't need to wait for it to appear in the database. It is in the cache immediately.
It's just that if you want to retrieve it, you cannot retrieve it by ID unless you implement an ID mechanism, and then that ID becomes a key in your cache instead of the last name. So I'm going to add as an owner, and then, okay. You see, I've been redirected to the find owners page. like I change in the code, and I don't have the error anymore. But yes, it may be a problem for your boss who is deciding about what page should appear on the website. So I think that's it for right behind.
There was one more thing. If you can stop and start again.
Mm-hmm.
Yep, restart the app. Just because you have your auto-completed stuff, and I wouldn't want my phone number to be there. So if you add yourself, and then immediately search yourself.
Oh, maybe then I should. Okay.
Do that.
5 seconds is going to be a bit short. Yeah. Let
sure,
me,
if you want.
Yeah, let me.
You can put it on the right behind delay then.
Oh yeah. Okay.
So what we want to do here is actually search for him before he's been saved into the database. Because if you remember, we've got a second cache on the search.
Yes, so it's not in the search cache. It's in the owner cache.
Yeah.
So it means that it's not going to be there when I can save, when I'm going to save myself, it's going to be available in the owner's cache. But because when I do a find, I'm looking inside of the owner's search cache, I'm not going to be there. But after it has been written to the database, so after a couple of seconds, then when I will do a find owners, I will find myself because it will have been loaded from the database. So again, and then looking for myself. No, not there.
So now we wait a bit.
Not there.
We can go back to the logs, see that the insert is being performed.
Mm-hmm.
So insert has been,
and
still
then,
can't find him. Why? Come on, tell me you're following. It's been written. So you see, the insert has happened. It's the last thing. Go back, search again. Not there. Exactly. The search has been cached. And the search was executed before it was in the database. So we now have inconsistency inside the application because of caching. On one side, we know he exists as a unique owner. On the other side, we're unable to find him through search. And so we've moved from cache aside for search to right behind for owner's creation. But we still have two caches for related data. We need to perform invalidation when we do creation. And again, since the only thing we're doing in search is using the last name or the last name bit that was used. So for example, search yourself removing a few letters.
like this.
There is. He's there. No problem. But that's because it's a new search criteria. And so you need to make sure when you start caching, and especially caching related entities, potentially in different caches, you need to think about the consequences of mutation in one side, even though everything is happening fine for that cache because it's cached through and you're really benefiting from that pattern. It doesn't mean that the rest of the application doesn't have consistency issue with what happened. And that's exactly what's illustrated there. So it's not because you go with the more advanced patterns that you've resolved everything. The problem is, as soon as you cache, you duplicate data, and duplicating data is a problem in the long term. Well, the good news is, we set what? Some time to leave there? Or maybe we didn't, I can't remember. But you remember when I did it with the hcache configuration in XML, we said after 60 seconds, the result goes away. Well, maybe that's a perfectly fine scenario for your use case, and then you don't have to bother about search cache invalidation. But maybe it's totally unacceptable, and you want to be able to search for him immediately. Well, in that case, what we would have to do is we would have to make sure we invalidate the cache on the search, but not from the service. We would need to invalidate from the loader writer, because he's the one being called by write behind. And it's at that time that we change the data model. It's not when the service returns. If at the service layer I do my invalidation, I'm invalidating too early. If I search in between, I have the same problem. So it's really, caching can help. But think about all these interactions and try testing all this stuff. That's really the kind of problems you end up hitting when you start caching.
Yes, so there are really two ways to use a cache. The first thing is to put the cache, get a cache, use it to cache stuff, and not go beyond that. That's very easy, very fast. You can do have some great performance improvement very quickly. But then, if the second option is to try to do something more complicated, like we've seen, and it can go. Yeah, you really have to think about how you organize your data. You have several options. Here you could have like one cache only for the owners, and then the owner search would fill up the owner's cache, and you can have many configuration, many different things. So you really have to think about your use case. What's the best way to design your cache usage?
Well, here, because we've added that stupid sleep, yes. And since the write all is a dumb implementation that just iterates over write, not only will you wait 5 seconds, but you will wait 5 seconds per entry. But don't code your loader writer with a sleep.
Yes.
I mean, putting sleep in code makes no sense. In tests, probably neither. So that's just for us to show you, like to simulate the latency because everything is local. But yeah.
Or you put a thread in your code, and when it's in production, then you remove it, and then your boss is very happy because you improve the performance of your application. But yeah, of course, no, it's just
the real wait time you'll get with batched write behind is the maximum wait time you configure, and if you've got incomplete batches. Because there you're saying, I really would like to batch, I don't know, 10, 20, 100 operation at once, because it's then more efficient. I open the connection once, I write everything, and I close it. But after a while, you say, yeah, but the problem is sometimes I only get 20 modifications out of 100, and I probably shouldn't wait forever. And that's also why we're using all these builders and stuff. It's because it helps us, when you use the EHCache 3 API, it helps us indicate to you what are the mandatory things. In EHCache 2x, you also had the write behind stuff. You could actually configure it in a way where it would do really, really weird things. Because you were telling it to do some special, and it would be not doing what you wanted to do, most likely.
But it's really like designing your application. I mean, you can write some spaghetti code, and then something is going to happen to your data, and you don't understand. With the cache, it's the same thing. If you design the usage in a sensible way, like you write something in the cache, you know that when you write something in the cache, you expect that you should read it, and you see that regarding your configuration, you have this kind of things like write behind which can make this case happen. Normally, it's not a big problem. Really, it's about designing your application correctly.
So I'm going to switch back to the slides. So, quick summary on that write behind thingy. Well, again, not only did cache through impact some of your domain modeling, going with write behind potentially has even more impact. As Aurelien showed, yes, it improved the latency problem, but it broke the application navigation because of that asynchronicity. Sure, the goal was scaling out your writes, so that's done. Again, batching, coalescing can help even more, because then you can potentially write bigger at once, or even write less if you coalesce. The durability in all that, because you've moved to asynchronous, but it means when the cache returns, when your service operation returns, nothing is in the database yet. Well, you may have durability requirements with regards to that. So that then depends on the queue persistence, and EHCache 3, it will depend on what kind of cache you have. If you have a pure in-memory cache, well, this is most likely gone if the application crashes. And also, it becomes, when you think about distributed setups and stuff, it becomes important to start looking at your operations as idempotent, because most often, what's guaranteed is that we will write at least once. in some failure cases, we may end up writing more than once. And so it's important that your operation, like if you're counting page views, you probably don't want just to do a +1. You probably want to indicate that this is +1 with ID X, and so if +1 with ID X happens again, you don't count. At the same time, if it's page views, maybe a few more page views are not so bad. So just depends what you're doing. Let's look at scaling now. So was there any question on the patterns and stuff? Okay. So if you want to scale, well, in today's world, and different caches provider offer that, one thing you can do in order to scale up is to move off-heap. Who doesn't know anything about what off-heap is?
Oh, who knows off-heap?
Or knows of, yeah.
Who knows off-heap?
Okay, so quickly do. So what happens when you've got a large heap in your JVM? You usually have problems with garbage collection. Nowadays, large heap can go to 100 gigs, depending on the time you're ready to spend tuning a garbage collector and stuff like that. A few years back, we were talking about below 10 gigs. The idea with off-heap is that instead of storing the data on the heap under the garbage collections control, you store it in process, so it's still in process memory, but it's outside of the garbage collections control. It becomes controlled by whatever allocated that memory and needs to be managed by that. Well, what it means is that if you've got a well-known life cycle for your data, off-heap is a pretty good candidate. I mean, and that's ideal for cache. You know exactly how long the data should live in the cache, expiry. You know exactly how to get rid of data, eviction, invalidation. And for the rest, well, it should be there. Of course, nothing is free. So if you start using off-heap, you'll get a performance hit because you will require serialization and deserialization of your data. Because what's stored on off-heap can't be just a plain Java object as a reference, because having a reference to a Java object implies a large number of things, which the reference being found, the reference staying where it is, but what's pointed at being moved around in memory by the garbage collector. And so if you don't have a garbage collector, you can't do that in off-heap.
If you're interested in off-heap, we have an implementation, so it's open source, it's on our open source GitHub. So an API to do some allocation and store and retrieve data off-heap.
Yeah, and you've got map and basic cache implementation, and it's what EHCache 3 uses in order to provide its off-heap capabilities. So that's open source, that's Terracotta. Hazelcast, they have an off-heap solution. I can't remember if they have a free off-heap solution. And other caches have started doing off-heap things. So that's the way for scaling up. Clearly, you start using more local things. You can also do caching on disk, but as I said, in today's world, it really depends. The one thing that caching on disk can help is that when your application goes down and startups again, potentially the cache data is still there on the disk. And it might be closer at hand than having to really retrieve it from elsewhere. The other way of scaling is clustering. Instead of scaling up, you scale out. What you do is you start sharing your cache between multiple machines. We have different topologies there, peer-to-peer architecture, client-server architecture. In the client-server model, you can even have with or without client caching. So you have a server holding your cache data, or a set of servers holding your cache data, and the clients connected to them. And some of these clients may actually hold a subset of the data, so that you've got like really, if you picture it, it's really CPU-like. L1 is way closer to the application, and the higher you go into the L number, it's farther away.
Yeah, level 1 cache in a CPU is really the one which is closest to the application, but it's also the smallest cache. Level 2 is bigger, but it's a bit slower than level 1. And here it's exactly the same. You have the level 1 cache, which is close to the client, to the application, and then you have level 2 cache, which is at the server level. So it's bigger because you can have many servers, a cluster of many servers, but it's a bit slower.
And of course, consistency becomes a much harder problem. You're entering the world of distributed systems. There is no free lunch there. So, of course, you hope that the caching library you use takes care of most of that, but it still be exposed in one way or another in your application. And for example, one thing is, that's a mouthful, probabilistically bounded staleness. What the heck does that mean? How long for a write to be readable by all? When you've got a distributed system, this is a serious question. You write to a given node, and that node has replication for high availability, all kind of things. How long does it take so that everybody, like all the clients of that cluster, do see that exact same value? And while they're waiting for seeing the same value, how many old versions are they actually seeing? Because if you remember the stories we had initially on the cache coherence, where it was like, I write A, he writes B, then I want to see B after a while and stuff. Yeah, but it could be A, B, C, D, E, F. And do you have a bound on there? So not only everybody seeing the same value, but also a bound on the number of old value you see for a while. Or is that also unbounded? Meaning that you can potentially see the oldest value at one point. And all of that, well, depends on a number of things. The network delay. How much time does it take for a given node to process an instruction? Maybe you've introduced even more delay because you wanted to do batching. And so these are really things that you need to take into account when you start looking at clustering. And so in order to give some concrete example, we're going to do a few slides on Terracotta explaining how it works. To be clear, there is a Terracotta version which is open source, and I'll mention when I'm describing stuff that are enterprise. It's going to be really quick. It's one thing in the 3 coming slides. So the way Terracotta works is you've got a local cache in your application. It uses the EHCache API. So that's pretty straightforward, nothing to change at the code level. It's just configuration based. What that cache interacts with is with a remote server, which is the active server, which contains your data. That server can be backed up by mirror server for high availability. So if the active dies, the mirror takes up. You can have multiple mirrors if you really want to support potential multiple failures at once. That's the enterprise feature. You can shard across multiple, what we call stripes. So the sharding is an enterprise feature, but otherwise, that's all open source. What does that mean? Well, we discussed the big problem of consistency. What happens if you want strong consistency in such a system? You've got your cache, the application doesn't appear anymore. The cache talks to the Terracotta client, which then interacts with the server itself. If something arrives in the cache, it goes to the Terracotta client, is sent to the server. But you're not the only client. You've got other clients there. The problem is, if you want strong consistency, when your operation terminates, no one else should be able to see another value than what you put. That's what strong consistency means. So what happens is that before returning, the server has to talk to the other clients and tell them, please invalidate any local reference you could have to that mapping. And you've got to wait for these servers to answer, because otherwise you don't know when they can process that. And only when all have answered, then you can finally return. Well, let's be clear. This has a cost. It's not for free. You see the number of, even if you have the fastest network available, you still need way more hops than the shortest path. The good news is you can do better. If you can relax your consistency requirements, then you can move to eventual consistency. What does that mean? We go to the cache, go to the client, go to the server, send the invalidation, because we still need that. If we didn't send the invalidation, if you remember these staleness questions, well, potentially all the clients could keep the values locally for as long as their expiry duration. And then suddenly you start losing limits on these bounds of when will everyone see my stuff. But immediately after the invalidations are emitted, in the case of eventual consistency, you can return to the client and tell it, I'm done. Of course, during that time, some other clients may already return saying, I've invalidated, but you actually don't care. The client tells the cache, it's done, the cache says, operation done. That's it. And then at one point later, all the clients finally complete their invalidation. So what happens here in that case is that we've bounded this eventual consistency by the time it takes to propagate to all the servers. In practice, a few hundred milliseconds, if you've got proper machines, proper network. But sometimes, some machines may see values for a longer time. Is it acceptable? Well, it depends on your business logic.
Yeah, if you want to take an example, let's say you have a couple who have a joint bank account. So a man and woman, they have $10, and then the man removes $10. You want to be sure that when the woman tries to remove $10, she knows that now they have zero on their bank account. So you need strong consistency. The man removes something, the woman knows immediately. And on the other end, eventually it's something like Twitter. We're going to post something. Not everybody is going to see your last tweets, but it's okay. Maybe it's good they will see you 1 second later, but it's okay. So it's really dependent on your use case.
So that concludes what we had to say. We'll probably switch back to the slides once more, though, to show some of the graphs.
Sure. Yeah.
Just showing a bit that even if you're doing everything locally, adding caching has a visible effect.
Yes, so like we indicated earlier, so I've got an open source project which is about doing performance testing, so basically doing some performance testing on whatever you want. And I run some tests on this application. So there is a part which is with no caching and the part with caching. So I'm just going to show you quickly the graphs. So the response time, when you look at a query, so I was doing like these find owners, and the response time I had was about 0.33 milliseconds. So yeah, it's very fast because it's local. So yeah, but with a cache, the same query take 0.012. So it's like what, 20 times faster, and you see it's quite stable. The interesting thing to look at also are the percentile distribution. So in case you don't know about that, percentile distribution is what is the distribution of the latencies. Which means that here on this graph, so it's a percentile distribution of the latencies. Here, this graph, you read it like this. Here I'm at 0.8, it's 80% of my queries are lower than 0.37 millisecond. 90% of my queries are faster than 0.42 milliseconds. Percentile distribution in performance is very useful to do some comparison of an application, of different application runs, because it helps you to compare, okay, what are the 99% of application of performance better than. So here I've got the non-cached one, and you see it's like most of them, are like until I think 99%. Yeah, 90. Yeah, let's take 98% are lower than 0.48, 49 millisecond. The cache version. Let's look at the percentile distribution. So I'm going to zoom. So you see immediately that most of the latencies are much lower, so it's much faster, actually. And if I zoom, so here I've got 99% of my call took at most 0.48, so let's say 0.5 millisecond, half a millisecond, 99%. Here, if I look at 99%, I've got, 0.003. So you see, It's like way faster, even on this local machine. So, yeah. Again, when you do some caching, measure your performance to see what is the gain, and especially try to different configurations, and really using this percentile distribution of latencies is a really good way to compare your different runs of your cache configurations.
And don't stop just at mean times and stuff like that.
Of course not.
Because you could improve the performance of most of the calls and then actually degrade the tail of your latency. And
yes.
As long as you've got large number of users, 99%, over 1 million, I mean, that's like 10K users seeing these times. And you may not want to like have availability problems for 10K users. So it's really important to look at that from...
Yeah, and about that, like, we can look at this graph. So you see here, so it's our caching. I think this run was with the cache side, so no, really the first one. And you see on average, it seems pretty stable. So if you were measuring the mean, you would say, yeah, hey, it's okay, we have, it's pretty stable. But this is actually the average. When you look at the actual numbers, you see that there are spikes. So here it's okay because it's very fast. So between, well, actually I'm looking at the TPS, but it's okay because it's very fast. You know, it changes from like almost 300,000 TPS to 320,000 TPS. But the thing is, yeah, you cannot trust the mean. You really have to look at the complete picture by looking at how was your cache behavior, your cache performance along the time, and looking at the distribution to show what are the really worst, the less performant cases. Yep.
How did you generate those statistics? Where did you get them?
It's with my framework. I can write. I write some Java code. I write. Okay, we have 5 minutes. Okay,
yeah, sure.
let me show you quickly.
The session is until 6, right?
Yep. Yeah, so if you've got questions, shoot. So we're going to end up on the Q&A slides anyway, soon.
Yes.
Minus F.
Yeah. So I think I got here. Yeah. So yeah, it happened when I wanted to compare EHCache 2. It was at the time of EHCache 2. I wanted to compare EHCache 2 versus JCache, the JCache implementations. And then I had to do some code in Java to use a JCache cache and to use EHCache. And then I realized something about performance testing is you have a couple of things that are always the same. One is defining a scenario, what you want to do in your performance test. Second thing is executing your scenario. Third thing is measuring the statistics of your performance. And fourth thing is reporting, like giving this kind of HTML report. So I wrote this framework which allows to do these four things. And the only things which differs from one application to the other is what kind of operation you do. If you want to measure the performance of a web application, you're going to download a page. Your operation is going to do a HTTP GET. If you want to measure the performance of a cache, your operation is going to do a cache.get, cache.put. If you want to measure the performance of your database, your operations can be like an insert, delete, etc. So in that case, so it's in Java, I have written an operation, and this operation is basically using the clinic service, so the service we've seen, and trying to do a find owner. So here I was doing only with one name because this is how I could measure what was the difference with and without caching. Without caching, it does the select every time. With caching, it does it once, and then it doesn't do it anymore. And then, so yeah, it's really, again, it's an open source project. So if you want to measure your application, you can have a look at it, and then it generates this HTML report. Yeah.
Where do you store it?
On GitHub, yeah, on GitHub, yeah.
You've got some
Yeah, I can. It's on GitHub. The URL. It's. I can give it to you after if you want. Yeah, no problem. Generally, you can. We have what Terracotta OSS GitHub. We have hcache GitHub.
Yeah.
Maybe that's something we should give the URL of our GitHubs.
Yeah, I can.
We can have a look maybe after at our GitHub pages. Yeah.
So I'll switch back to the slide just to check. Like we said, conclusion. So good, you know it all. Have fun with caching. Again, I think what we tried to convey, and I hope we succeeded with that, was understand your needs and what caching could bring in your context. And then, as you've seen, you probably should consider it early on, especially if you want to move beyond cache-side, because then using these other patterns has an impact on some of the modeling you need to do. So for that, think of it as soon as you can. And that's it. Thanks for your time. If you've got questions, please shoot. Otherwise, I can quickly switch to... how am I going to do that? Exit that. There.
Okay, you can think about questions while we are looking at the open source repository.
There. So first of all, EHCache website, you'll have a number of resources, including older presentation that are linked to it. And there is a link to the GitHub project. So you've got EHCache 3 itself and a number of other things, including the size of library. EHCache is one of the caches that allows you to size objects on heap. So you can define the heap cache in memory, like 100 megs. So that's pretty convenient. And then if you switch, you've got another repository on which you'll be able to find all the stuff about Terracotta open source. So you've got the upcoming version of Terracotta, but you also have here the off-heap store, which is the off-heap library. Documentation is not its strongest point, but there are resources online to explain it. Sadly enough, we did one demo with code, but it was in French. But if you can still read the code, even if you can't understand the French, it should show you that it's pretty easy to do that kind of stuff. We don't use unsafe in that library. So that library has no use of unsafe. So it's actually a vanilla Java library, which will probably be modularizable with Jigsaw without too many problems. So yeah, and I guess your stuff
is on AUR with my name. Can you type it? AUR, like my Twitter handle. I think it's auto-completed.
Is it?
Yeah.
Oh, because I went to the sprint when we're prepping.
You go to the repository and performance framework is called Rainfall, so you look at the Rainfall and
Rainfall core and stuff for EHCache. Sure. Mm-hmm.
There is no way that both the clients at the same time would, after the expiry date has reached, then inform the server that the cache is now invalidated, right?
So the question is about the clustering solution having a notion of absolute time across the client and the cluster, and what happens with expiry. No, you probably have small races there. So you need to account for that when you compute the expiry. So you need to make sure you're not like on the fence. But if you think about it, expiry, if you're at the nanosecond, there is probably something problematic in the caching. Because if you rely on expiry, it's because you want the data to become stale kind of at its own pace. If you really want strict precision, then you really want to go with invalidation. Because then you say, from now on, this is no longer valid. Because just if you think eventual versus expiry, well, if you're ready to do eventual invalidation in order to not pay the price of the synchronization of all the clients, why would a few milliseconds of delay between the expiry be a problem? Again, I'm not saying you don't have that problem. I'm just saying realize that if you have that problem, then your only answer is strong consistency in validation. Any other question? Yeah.
Is it a good idea to put the version number of your application in your cache key? So, for example, if you have a shared cache server or cluster, and then you have, say, 2 app servers, and they're running different versions. So you might have the same object in your shared cache server, but they're the same thing, but they're different classes because they belong to different applications. Is that a good idea, or is there any best practice in terms of invalidating both versions of the object? It might happen, for example, in a rolling deployment.
Okay, so the question is about what kind of strategy you can put in place when you've got rolling upgrades and stuff like that with a clustered cache, where suddenly the code for what's contained in the cache could change. And so the question is, should you put, for example, something like the application version number as part of the key? Honestly, that's really a business decision, because if you think about it, first of all, the rolling update is a problem if you're effectively changing the class and relying on plain Java serialization. If you've decided to rely on custom serialization, you could do what's necessary to not have that problem. And if you still have the problem, or if that's really something you realize, crap, it's really happening often and often, yeah, maybe that's the point. But if you do that, then really what you're saying is that when you're doing a rolling upgrade, what was in the cache will slowly go away and be replaced by the new version of the application because it's no longer shared. So again, balance. Yeah.
With serialization, anyway, you will have, because the serialization version ID is going to be different, what you put when you try to deserialize it is going to fail.
Yeah, but if you go to custom serialization, you could potentially alleviate the problem yourself. So that's really depending on. Yeah. Yep.
I have a question on the right behind pattern that you
Mhm.
explained earlier. What if, I mean, it goes asynchronous and I get that. What if a write on DB, for example, fails because of, the database constraint or something like
Yeah.
that? What's the best thing to do, in order to...
So that's interesting. So in the context of cache, if you remember, one of the features we mentioned as important is the fault tolerance thing. In the context of cache, and it's not there yet, will be coming, what we really want to do in that case is make sure we invalidate the cache entry. It's probably too late to tell your application because the thread is gone. So we can't tell your processing that what happened was invalid. But at least we should invalidate the cache so that you're no longer caching something that you know is invalid. The whole plan, and it's an upcoming feature, it's not there yet, is that we would enable you as a user to configure what we would call a resilience strategy, which would be invoked when such situation happens, and so that, since you know best, you would be able to do what's needed. Whether it is, let's go invalidate the cache, or crap, I should retry, or damn, the world is on fire, system exit. But we want to find a way to give that control to you, because indeed, through the asynchronicity, it can't be your application processing thread. Of course, in order to not have that problem, make sure you do the proper validation up front. But like you've said, if it ends up being a constrained validation error in the database because some other application changed the database, why would they do that? But that's the plan we have. It's not there yet.
Thank you very much.
Anything else? What?
When it comes to this terracotta caching, okay, we can imagine that there are not only nodes which are the clients of the terracotta client, but there is, for instance, like direct access to the database, for instance. Yeah. Can we somehow integrate this as a terracotta client that will be able to as well invalidate?
Yeah. So what you'll do in that case is potentially make one Terracotta client running next to that other stuff which modifies the data. And in that case, what you could do is have a client which has no near cache, because you never want to read from that client. So you don't need a near cache. You just want to actually push the invalidations. Well, invalidations are what? They're removes. That's really what you're doing. So yeah, you can do something like that. I'm not sure I repeated the question though. So the question was about how to handle if you've got multiple clients, but you've got some specialized clients that are mostly doing invalidation. Yeah. Then that's it. Thank you, folks.
Thank you very much.